You could have graphed this on the calculator. What you do is you have your, and you would have had to use the log base or the change of base. Either one would have sufficed. You would have done, okay, the log of, well, we'll do the log base. So we do the log base three of x minus log base 3 of two x minus 1. And then you compare that to where it's equal to 0. Well, you just graph it. And then you tell the calculator to find the 0. And so here you have your left bound. There you have your right bound, and you tell it to guess. And it evaluates the 0 at 1. So you could have done it algebraically, or you could have done it graphically. Now, the same holds true for number 10. You could have plugged this in as your y1 and this one as your y2, but again, that's not very sporting. So what you would do is, here you have a addition symbol, but you also have the 1/2. You have to deal with the 1/2 as a multiplier. And what you had to remember is that your coefficient of your log becomes an exponent. So now you have the log of x plus the log of 16 to the 1/2. Well, 16 to the 1/2 is a square root. That's the log of 64. Well, so now we have the log of x plus the log of 4 is equal to the log of 64. Now, I know it's tempting to subtract the log of 4 from both sides and say that the log of x is 60, but that's not what you do. When you're adding logs, you're actually multiplying the terms. So now you have the log of 4x is equal to the log of 64. Now, since these both have the same base, these are logs without a base listed, so that means they're base 10. So what you can do is you can exponentiate by 10. So you say 10 to the power of this and 10 to the power of this. Da-da-da-da-da. Base cancels log, and log cancels base. So now you're just left with 4x is equal to 64, and then you just divide by 4. And so x is equal to 16. So that was fun. All right, now, next one. Caroline wants to start a college fund. She's got $750 in savings, and her money is set to double in 10 years. When compounded annually, what interest rate does the bank pay on her savings account? Now, this one was fun. This one was actually pretty cool. Okay, so you know that her function as a function of time is equal to 750 times 10, or sorry, times 2 to the power of the time divided by 10. Now, this is not really a logarithm problem. Really, what you're trying to do is you're trying to figure out what 2 to the 10th root is. If you're actually going to find the base, you are going to take the 10th root of 2. Now, for that, you might rely on your calculator. So what you're going to do is you're going to take your 2, and you can go on ahead. You go to the math, and you go to the 5. That is where it says, oops, I screwed that one up. All right. Not that one either. Here we go. So you go to the math, and you go down to the x root. And so it's going to ask you for a root. And you say, okay, I want the 10th root of 2. And so it's got 1.0717 and so on. And so on. Now, what it is asking you for, it says, what interest rate does it pay? And it says round answers to the nearest thousandth. Okay, so thousandth is 3 decimal places. Now, what was kind of tricky is they said rate to the nearest thousand. They did not say as a percentage. And so you subtract 1 and you find that your rate is actually 0.707. Now, tenths, hundredths, your thousandths is not 1/7, you have to round it up to 2. 0.072 is your final solution. Now it's kind of tricky because you're used to dealing with your rates as percentages, and even in the previous question it dealt with the rate as a percentage. Now, number 12 was, shall we say, a little bit more interesting. Okay. And in some ways it was less than instinctive. Okay? So, and in terms of the actual grading, I think I'm going to be tempted to throw that one out. Because basically if you graph it, let's say you graph x squared minus 9. And then you take just the log of x. Since they didn't give you a base, you can be arbitrary about it. So I just use base 10 because it makes my life easier. So when I graph it, here I have my nice beautiful parabola. And here, my log hits the axis here. But the other thing you have to remember is that a log function has a vertical asymptote. It never did cross the axis. And at some point down here in the undefined, in this area right here, it is going to cross the axis. Now, finding it algebraically, that's all kinds of fun. So we know visually that it's 2, but the algebra behind it is a little bit uglier and kind of more than what I want to get into right now. I may have to post a follow-up on that, but I'm trying to keep this video under time. Because the upload on this takes forever. Alright, now let's take a look at number 13. Merlin Industries 2100, it is expected to depreciate at a rate of 14%. So what you've got is your amount as a function of time is equal to the 2100, which is your leading coefficient, times 1 minus 0.14, and you are evaluating the function where x is equal to 5. Now, this one I would go on ahead, plug it into the calculator, and then just scroll down to where it's equal to 5. And then I would just scroll down to where x is equal to 5, and you find that it's 1148.7. Oh, 14% per year. What will it be worth in 5 years? Hang on, I must have done something with law. Depreciate at a rate of 14%. $2,100, 1 minus 0.14. Oh, 5 years. Don't be me. Can't read the problem. So, 5 years, 987.9, which is about 988. There we go. Alright. Now, these ones were, shall we say, a little on the fun side. These were thinking man, writing man questions, or thinking girl, writing girl questions. Okay, so basically, they were basically trying to ask you, hi, do you recognize that a logarithm cannot have a negative term? Okay, and so what you can do, if you can't visualize it right away, is just graph the log of x, or the log of x minus 3. And you look at it, and you see you have an asymptote, and you scroll down and you find that you have an error until you get to 3. And there you go. So that tells you your domain is the set of x such that x has to be greater than 3. Now, if you want to list it as an interval, you could always do it as the set of x such that x is between 3 is less than x is less than infinity. And if you're one of those interval notation types, 3 to infinity. Any of those would work. Okay, explain why log 2 of negative 8 cannot be solved. What they were asking you to do was to recognize that 2 to the x cannot equal negative 8 because one cannot multiply a positive base by itself to get a negative term. And that's it. Okay. Next one, you are being asked to find the rate. Now, you know it's a rate of decay. And so what you're going to do is you are going to take 19 and divide it by 20, and you're going to get 0.95. And then you're going to take 18.05 and you're going to divide it by 19. And you're going to find you're going to get the same thing. And just to be sure, you're going to take 16.29 and you're going to divide it by 18.05. And you're going to get something that's not quite right, but the first two iterations are close enough. So, what I'm going to do is I'm going to set up my function as my f of x is going to equal the 20 that I start with times 0.95. They weren't asking me for the rate. I'm going to set it to the power of the x. Then what I'm going to do is I'm going to plug it into my calculator as 20 times 0.95 to the power of x. And then I'm going to go to my table to see if it matches. And I find, lo and behold, it works for 0, it works for 1, it works for 2, for 3, and it actually does work for 4, but I don't know why it didn't work out too well. Oh, because the shift was from 2 to 4. That's why it didn't work out very well. Okay, so now that we have our rate, we're going to try and find out when there are approximately 12 milligrams in the bloodstream. Now, the milligrams in the bloodstream is a y variable, so we're going to go back to our calculator, and we're going to go to where y is equal to 12. And we are going to graph that. Now, right now, we are not going to see all of this because this is outside of our standard window. So we're going to go to our window, and we are going to go from 0 to 10, and we are going to go from 0 to 50 by intervals of 5, just so we can see it. And so there's our decay curve. And then there's our 12. And we're going to trace our point of intersection, second trace. And our point of intersection is 9.95, which is about 10 hours. Now, on the back, they had asked you to show the graph and the algebra for 16 and 17. Okay, the graph is not as interesting as perhaps the algebra, but let's just go with it anyway. We know our graph is in the first quadrant, so the first thing I'm going to do is I'm going to go on ahead and do my graph. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. And this should be 1, 2, 3, 4, 5. Oh, really? That's not 20? Hang on, let me double check. 5, 10. Okay, here's 5. 1, 2, 3, 4, and 5. Here's 20. And we'll do the same here. 1, 2, 3, 4, and 5. That's 5. 1, 2, 3, 4, and 5. That's 10. 1, 2, 3, 4, and 5, that's 15. 1, 2, 3, 4, and 5, that's 20. Now, what we're going to do just to make our lives easier is we're going to go on ahead and we're going to plot the constant line that they gave us, because we were looking for where it was 12 milligrams. So we're going to go up to 12 milligrams and we are going to strike a constant line. A constant line, of course, is a straight horizontal line. So here we go. We got that. That was fun. And now we're going to go back to our table and we're going to plot a few points. Now, the other thing we could do, just to make our lives a little bit more fun and interesting, is we can go back to our table for a moment. And actually not. We'll just go to our table and we're going to try and make some nice integer points. Well, we know we got one at 20. We know we got 20, we got 19, and we got 16 and a few others. So we got 20, 19, and we know that right about 10 we're pretty close to 12. And we're going to see where we get where x is equal to 20, see if it gets to be anything good. Where x is equal to 20, you're just above 8, or you're just below 8. So here's 5, here's 20, here's 6, here's 7. So it looks something like this. It doesn't have to be perfect. And that's the graphical representation of it. Now the algebra behind it was, shall we say, just a little bit more fun. We had our f of x is equal to 20 times 0.95 set to the x, and we set that equal to 12. Well, 12 is 20 times 0.95 to the x. We're going to divide both sides by 20. And so now we've got 12 over 20, which is the same as 6 over 10, which is 0.6. Is equal to 0.95 to the x. Well, at this point, we're going to take our log. We're going to take the log of 0.6 is equal to the log of 0.95 to the x. X becomes our coefficient. So x log of 0.95 is equal to the log of 0.6, and we end it with our change of base. X is equal to the log of 0.6 over the log of 0.95, which we can then plug into the calculator and evaluate. And so plug it into our handy-dandy calculator. We say, okay, the log of 0.6 divided by the log of 0.95, and we close it up, and we get 9.958, which was about 10. And that's it.